Welcome to Calculus BC. What is calculus about? Calculus gives us a way of dealing with things that are infinitely small, what is called the infinitesimal. Our ways of dealing with the infinitesimal have to do with things that are infinitely large, the infinite. Calculus is about the infinite and the infinitesimal and the relationship between them. It's about things that change continuously over time. You have techniques for dealing with things that are changing so far, such as slope. We have rise of a run, or it can be rate, that is distance divided by time. But all those assume that the rate you're traveling at, or the rate something is changing at, is constant. The rate itself does not change. By dealing with infinitely small increments of change, calculus can deal with change that is itself constantly changing, and it can be constantly changing at many levels. Calculus also deals with using this kind of infinitesimal change to get a handle on the totality that occurs as a result of a continually changing rate of change. So for example, if you have snow accumulation, the snow doesn't fall at a constant rate. The snow starts out falling slowly, and then the rate at which the snow falls increases. And what you'd be interested in knowing is what is the total amount of snow that falls over that time. But since the rate of change is not constant, you can't use a lot of the techniques that you learn in algebra. So conceptually, calculus is going to take a very different direction. On our journey, we will be accompanied by Fela, I'm certain, but we will also be accompanied by a different kind of vocabulary and some new conceptual tools. So what I'm trying to establish is that unlike your previous classes where you learn algebra and then you learn more algebra and then you do algebra and geometry and you're basically learning to manipulate and calculate with different entities, calculus is extremely conceptual. You have whole new concepts. So one thing that's going to help us is to re-examine the concepts you already know at a more conceptual level. And that's actually what I'm going to start with here, is a sheet that is posted on the website, and it's probably also in the Google Classroom by now, that gives you definitions of sets and functions. Now, I'm going to assume you already know what a function is. You probably already know what a set is, although we don't do set theory as well as we should for people who are coming into calculus. You probably know what the natural numbers, the whole numbers, the integers, the rational numbers, the real numbers are. However, what I want you to pay attention to here is the kind of vocabulary we're using to describe them. So there's nothing written on any of these sheets that you don't know. You know what an interval is, you know what an open interval and a closed interval and a half open interval are. All right, but look at the language that we're using to describe them. And I developed this so that anything that you encounter in a line has already been explained up above. So if I don't know what this line is, go find it up above. Oh, that symbol means such that. All right, so everything is described here. A lot of things, again, that you already know. What's an ordered pair, what's a relation, but what are they really? So a lot of our start into calculus is a matter of looking at things that you already know, but looking at them more deeply and looking at them at a more conceptual level. So you domain and range graph, you know all those things, but again, try to relate the way that you already understand what domain and range are to the conceptual description that is here. And we want to try and build that conceptual understanding by appealing to things that you already know. Some of these things you might not know very well. Again, we don't teach set theory very well, but here it is. And here's some things you might or might not know. Probably very few people have seen this symbol. That's a fun one. So I put in some things that, like, you don't really need these symbols, but I like them. I will use them. These ones, these logical operators, we absolutely will need. So your job is to read this carefully, to download this and read it carefully, and look at, there's a little Latin lesson, there's a little proof of the square root of 2. So your first job is to read this carefully. All right, and so you're going to download this, you're going to read this carefully, and you're also going to, at the conclusion of this video, which is coming right up, I want you to think about this question. What is the smallest positive number? All right, so Read carefully over the document that describes the vocabulary. I think it's called something like sets, functions, and logic, or something like that. It's on the website. It's on the Google Classroom. And after you've done that, or maybe while you're doing that, think about the answer to this question. What is the smallest positive number? Now, I'll be discussing some of the possible answers to this question in the next video. So make sure you come up with your answer to this before you watch the next video. And by the way, you should keep a notebook for this class, even if you're just working from home. Keep a notebook just for this class and write this question and write your own answer down, even though, you know, if you're not coming in, I might not see it. But write it down anyway, because it's a good way to learn. And then when you watch the next video, look at what you wrote and see how it coordinates with what I'm going to discuss about it. So I'll see you in the next video after you read the material and answer that question.